It is section 8.5, integration of rational functions by partial fractions. In this section, we'll see how to express a rational function as a sum of simpler fractions, each of which is easily integrated. Such simpler fractions are called partial fractions. To illustrate the method of partial fractions, consider this expression. These simple fractions can be combined to become this rational function. Now, if you start with the rational function in integration, then now you may change this one into this form. Then each of them can be easily integrated. For this first term, the same as twice of logarithm x minus 1, right? And then for the second one, that is a logarithm of x plus 2, right? And integration constant c. Okay, that's the main idea of the method of partial fractions. Here we have a general description of the method. For the rational function f of x over g of x, the degree of fx must be less than the degree of gx. That means that the fraction must be proper. If not, you can divide f of x by g of x and express it in this way. F over g is now q plus r over g. R is the remainder and q is the quotient. And quotient is a polynomial, so that if you try to get integral, then easily you can get that one. And then for this one, now you can apply the method of partial fractions. Now here, if you want to use the method, then you must know the factors of gx. In theory, any polynomial with real coefficients can be written as a product of real linear factors and real quadratic factors. That means that for any polynomial, you can factor out with linear factors and the quadratic factors. Okay, here let's see this example. Let's begin with this rational function. Now we'll try to express this one into these partial fractions. Now factor for g of x, the denominator, one factor is x plus 1, the other one is x minus 3. So we are trying to express in this way. Now after some manipulation, you can decide a is 2 and b is 3. Let's try to do it here. From this one, now the main task is to decide a and b, the undetermined coefficients. Okay, from this one, if we take the common denominator, then there will be x plus 1 and x minus 3. Then for the top, okay, that will become a x minus 3. And for the second term, it will become b times x plus 1. Right? Then now the numerator can be written in this way. The coefficients of x is now a plus b. And then the constant terms are minus 3a and plus b. And then here the same denominator, right? Okay, this expression must be the same as that one. Right? That means that if you compare the coefficients, then the a plus b must be 5. Okay, let's write right here. A plus b must be here, that is 5. And then now minus 3a plus b, minus 3a plus b must be minus 3. So we have to solve this linear system to decide a and b. Okay, now number 1 equation, number 2 equation, we are subtracting to eliminate b. We subtract number 2 equation from number 1. Then that is now, okay, left hand side will be 4a, and b will disappear, and right hand side becomes a. So from here, a becomes 2. Okay, now once we decide here a, then from equation 1, here addition is 5, which means b is now 3. So we decided a and b, that is exactly this one, a, that is replaced by 2, and for that b, it is replaced by here 3, right? Okay, so we decide these partial fractions, and we start with undetermined coefficients. Now we decided them to get here the partial fractions. Okay, now for this expression, here the factors are x squared plus 1, this is a quadratic factor, and x minus 1 is a linear factor, but it is squared. In this case, you have to here assign in this way one quadratic factor, and the top must be linear. And for this one linear factor, for linear factor, it must be constant, and it's square, x minus and square, but the basic term is linear, so you have to put here now constant. So in this way, you start with the separation, and then try to decide here a, b, c, and d. Exactly same way you can do that. Okay, now we'll try to combine them. Then now here the common denominator will be x squared plus 1, and then here that is x minus 1 squared. And top, for top, here ax plus b, and now extra term, it must be x minus 1 squared, right? And for second one, c times, we have to have here x squared plus 1 and x minus 1, right? Okay, and for the last one, that is t times, okay, that is x squared plus 1. Okay, now you have to make the expansion, then the numerator will be changed into in this way. Okay, for, okay, that is x cubed. The coefficients must be here now. That is same as x squared. Okay, this portion, let's try to rewrite this portion only. For that one, it is same as now x squared minus 2x plus 1, right? Okay, now try to get coefficients of x cubed. From here, x cubed will appear with ax times x squared, so that here we have a, and then now from here x cubed, now that is c, and for the last one we don't have x cubed. how about x squared? From here, x squared will appear minus 2a, and then now x squared will appear here now b, right? And x squared, that is parenthesis. Okay. Now for no, just a moment. Now we have to continue here. Now we have for this one, and then x squared will be from here now minus c, and then for that one plus d. Okay, not b. Okay, plus d and x squared. I'm trying to write down with minimum writing, so it is a little bit complicated. However, you have to expand everything and then try to combine in this way. And so sometimes it is cumbersome. However, this is the way of getting here the numerator. Okay. Now the coefficients of x. Okay. From here, you can get there's a and minus 2b. Okay. A and minus 2b. And from here, now x term will appear when you multiply this way. So that now plus c. And for this one, there's no x term. Okay. And how about the constant term? Okay, we'll write down here the constant term. From here, now constant term is now just b. And from second one, the constant term is minus c. And from the last one, the constant term is d. Okay. Now, along with this expression, okay, the same bottom. Now here, a plus c, there's no cubic term here, so that a plus c must be 0. And again, this one must be 0, minus 2a plus b minus c plus d must be 0. And third one over there, that is now a minus 2b plus c must be minus 2. And then finally, that term here, b minus c plus d must be 4. If you solve this for equation for a, b, c, d, then you will get here a is 2, and b is 1, c is minus 2, d is 1. You can see here now a plus c equals 0, so that you can easily see that the addition is 0, right? Okay. So after solving this for equation, you can get a, b, c, d in this range. So you can check it. Now, for this one, now here, for the denominator, now one linear factor and quadratic factor has power 2. For that one, for x, you may start with a over x. Now for this quadratic factor, now the numerator must be linear. So it's quadratic and must be linear. And because power is 2, we have to put another one. However, the basic term is quadratic. The whole thing is, in fact, fourth order polynomial. However, the basic factor is quadratic. So we have to put here the linear term. So now, exactly the same as earlier, you have to decide A, B, C, D, E. Then you'll see that one. Okay? You can do it yourself. Here, we have here now strategy for the method of partial fractions. Assume here f over g is proper. That means that f has lower degree than that of g. Okay. Now, for linear factors of g, here, now x minus r is a factor of g with x minus r to the m with the highest power. Then, for this factor, you have to assign the sum of m partial fractions. Start with here a1 over x minus r and x minus r squared up to x minus r to the m, with all here the numerators are constant because the basic factor is linear, so you have to put here constants. But once power is larger than 1, then up to m, you have to make these fractions. We did this one exactly here, like that. And for linear factor, we start with 1 over x minus 1 and 1 over x minus 1 squared. Now power is 2, so that we put here 2 terms. And now all the numerators are constants, right? Okay. And now here, for quadratic factors of g, if this is a quadratic factor with n, the highest power, then for this factor, you have to assign this n partial fractions. And this basic quadratic and top must be linear, and the square for the squared, and we have another linear, and so on, so that we have to get here, okay, that must be n, okay. Okay. In this way, you can assign the sum of n partial fractions, and then now you can combine all the partial fractions for the rational function and then determine the coefficients. That's the strategy. Let's solve these problems. Okay, now this is not proper, so that you have to here now start with the division. Okay, let's try to divide them. Okay, here in this way, x cubed and plus x now, okay, divided by here x minus 1. Then we have now x squared, then that is x squared minus x, okay, x squared, then x cubed minus x squared, right? And once you subtract, then there's x squared. Now we have x, then x squared minus x, so that if you subtract, then there's 2x. Now we have here plus 2, then there's 2x minus 2, and remains 2. That means that the integrand is the same as the quotient, x squared plus x plus 2, and remainder is 2, and then the divider is now x minus 1. Now already this is linear factor, so that the given integral can be easily integrated. For this one, now 1/3 of x cubed, and for the second one, there's 1/2 x squared, and for this constant, there's now 2x. Now for that one, twice of logarithm x minus 1 and integration constant, right? How about this one? For this one, now you can do this long division. However, the numerator can be written in this way. here, that is now, if you factor out 2x, okay, 2x, then that is now x squared minus x and plus 1, right? So that along with that one here, that will become 2x, so that integrand is the same as now, okay, this portion here will make here 2x, and then remaining part is now 1 over x squared minus x. Okay, we rewrite this one in this way, 2x and factor, that is now x and x minus 1, and now top is 1. Okay, now we'll focus on this fraction. It's a proper rational function, and we'll try to get partial fraction for that. Okay, here 1 over now x minus 1. For this one, now a over x and plus b over x minus 1. Then now we combine them, x minus 1, and for the first term we have a x minus 1, for the second one b of x, right? So that now that can be coefficients of x is a plus b, right? And then coefficients of constant, the constant term is minus a, right? Okay, now the same bottom, x minus 1, there must be 1 here. That means a plus b must be 0 and minus a must be 1. Okay, which means b is 1. So the partial fraction is now determined. That is, a is minus 1, so that minus 1 over x, and here b is 1, so the 1 over x minus 1. Okay, so this term is already here partitioned. Okay, so the given integral must be integral of that one, that is x squared, and for these partial fractions, that's now minus logarithm of x, and for this one plus, okay, logarithm of x minus 1, and here we can put integration constant, right? Okay. Okay, now let's try to evaluate the integrals. For this one, now for the integrand, we may start with in this way. This is a linear factor, so numerator must be a constant and x plus 1. Because power 3, we have to continue this one along with now x plus 1 squared, and now another constant over here, x plus 1 cubed. Right? Now we have to decide A, B, C. Okay, in order to do that, let's combine them. Then common denominator must be x plus 1 here cubed, and now for the top, for that one, a, now x plus 1 squared, and for second one, now b, x plus 1, for third one, simply c. So here, for the coefficients of x squared, there must be a, okay, only a. Okay, now coefficient of the linear term, this one will make 2x, so that now 2a, and for this one, now b will appear, so that the coefficient is this one. Now it is 1, so that for constant we have a, and again b and c, right? The same here, denominator. Okay, so that must be same as now x minus 1. This top must be same as x minus 1, which means that a must be 0, and here 2a plus b must be 1, and a plus b plus c must be minus 1. A is 0, then now b must be 1, a is 0, b must be 1, then c must be minus 2, right? So we decided ABC in this way, right? Okay, now we already know here a, 0, okay, this will disappear, and then b is 1. What is the antiderivative of this one? That is minus of 1 over x plus 1, right? So that given integral is same as that one. First one will make a 0, and from second one, now that is, b is 1 now, b is 1, so that will make minus 1 over x plus 1 is derivative will make now 1 over x plus 1 squared, right? Now c is minus 2, so that is antiderivative will be 1 over x minus 1 here, that squared, right? And then integration constant c. Okay, now for that one, the integrand can be partitioned in this way: a over linear factor x minus 1, and plus, now for the quadratic factor must be bx plus c, linear term, over x squared plus 9. So we have to decide a, b, c. So after deciding this one, now, okay, you can separate two things so that you can get integral easily. Okay, now, okay, let's try to decide a, b, c. In order to do that, we have to combine them. So here, along with the common bottom, x minus 1 and x squared plus 9. And top must be here a, x squared plus 9. And the second term is here now, okay, bx plus c times x minus 1, right? Okay, so here coefficient of x squared is now a, and from here plus b and x squared. Now for x term, nothing from here. Now from this one we have minus b and plus c, minus b plus c x. And for the constant term, that is now 9a from this one. And from this one, now that is minus c, right? Okay, here, now this top must be 10, which means that a plus b must be 0, and minus b plus c also 0, and then 9a minus c must be 10, right? Okay, that means from here to there, if you add them now here, a plus c must be 0, so that a and c has opposite sign, the c is minus a, so that will become 10a. From this one, a must be 1. Then b is now minus 1. And here, b and c are the same, so that again, this is a c. Okay. So we reach at here. Okay. Now let's rewrite the integrand. That is, now a is 1, so that 1 over x minus 1. Now here that is minus 1 and minus 1, so that you can write down this one in this minus x over, rather than minus x minus 1, we separate it. Then there's x squared plus 9. And then now minus 1 over here x squared plus 9. Right? Okay. And now you can find the antiderivative quite easily for that one. For this one, it's logarithm of x minus 1. For that one, minus half, you can put over there. Now, you can manipulate in this way. That is now 2.5. Then it's derivative of x squared plus 9. So that antiderivative of this one is minus half and logarithm x squared plus 9. For that one, now here, that is, okay, this is, okay, multiple of arctangent x. If you try to get, for example, now, okay, let's see this way. Now, arctangent of, okay, rather than x, we think here ax, right? If you try to make a derivative, then that will be 1 plus the squared. That will be a squared, x squared, and over there, and derivative is a. So once you choose here, now a is, okay, so that 1 over a squared, so that a is 1/3, right? A is 1/3, then you can get it. So that one is antiderivative is basically, okay, arctangent, a constant multiple, something here, and now x over 3, right? Okay. And after getting each of them, and plus c will be the final answer. Okay, let's go to this problem. Okay, now for this one, and here only quadratic term and squared, so that the integrand can be written in this way. Integrand the same as now ax plus b over x squared plus 1 plus and cx plus d over here x squared plus 1 squared. Then now we combine to decide a, b, c, d. Then common denominator must be x squared plus 1 squared, and top here ax plus b times x squared plus 1, and from the second part now cx plus d, okay, itself. Okay, for this one, now let's try to get the coefficient of x cubed from here. From the first one, okay, only a and not here, so the ax cubed. So a must be 0, there's no cubed term. Now for x squared, okay, from here we have only x squared along with that b, right? b x squared. For linear term, the coefficient is, from here, we have a, and we have c here now. So a plus c x. And for constant term, okay, we have b from the first part. From second part, we have d, right? Okay, and the same bottom. Okay, from here, we have to match this one with that. Then a must be 0, and b must be 1, and a plus c must be 2, and b plus d must be 1. Okay, so a0, b is 1. From here, now c must be 2, and now b is 1, then d must be 0, right? So we got everything here. A is 0, b is 1, c is 2, d is 0. So that one, okay, we rewrite the integrand. Then a is 0, b is 1, so that 1 over x squared plus 1 is antiderivative is arctangent of x. And then for that one, here now, that is c is 2x, and here that is x squared plus 1 squared. So here the given integral can be now arctangent of x from this one. Now plus, okay. Now x squared plus 1 is derivative as 2x. So that must be same as now, okay. Now here antiderivative is same as 1 over, okay, x squared plus 1. Once it is differentiated, then square on the bottom, and 2x will appear with negation. Okay, so we put negative here. And now, finally, integration constant. Okay, that's the final answer. Now we'll go this problem. Okay, now once it is given in this way, then you may start with substitution. Then you see some result, and you may start with x plus 1 and is u, or the whole radical is u. Now we'll do in this way. Then now u is square root of x plus 1. Then now u squared is x plus 1, and here dx is now 2u du, right? Okay, and so that the given integral can be changed into integral square root of x plus 1 is same as u, and then for the bottom, x is the same as u squared minus 1, and then now dx is same as 2u du. So here we have that's twice of u squared over u squared minus 1. Now it's not proper, so that we put here minus 1 and then plus 1. So for this portion, it will become 1, and so that it can be written twice of integral, and then 1 plus now 1 over u squared minus 1 and du. Right? Now for that one, we have to get partial fractions. 1 over u squared minus 1 is, now that can be written as here u plus 1, u minus 1, so that a over u plus 1 plus b over u minus 1. now we have to decide A and B. Okay, so that is now u squared minus 1 on the bottom, and that is A u minus 1 times plus b times here u plus 1, right? Okay, coefficients of u is a plus b, so that is 0. So we write down here a plus b equals 0. And now the constant term is minus a plus b. So that minus a plus b is 1. And so that now here, from this one, okay, anyway, we add them, then 2b equal 1, so that b is 1/2. Then here, a must be minus 1/2. Okay, so this value is minus 1/2. That value is 1/2. Now you can get antiderivative quite easily. Here for that one, minus half logarithm u plus 1 and plus half logarithm u minus 1. After getting antiderivative, now u must be replaced by x plus 1. Then you can get the final answer, right? Okay, you can finish the computation. Okay, this is the end of the section. Thank you.